this particular table, you can see that in the table we have n, next 1, 2, 3, 4, 5, 6, and then Tn 0, 5, and 15. Okay? Then the last two boxes are blank. Can you tell me, looking at Tn, when I say looking at Tn is looking at this particular row, can you see a pattern that is happening to get the next term? What is happening? You are adding 5. So can you just fill up the next blanks? So fill up the rest 1 to 4 by looking at the pattern, and please add in the other column writing there, describe words. So for the first one, you can write for me add 5. Okay, that's in that column. So how about the rest? Is it adding whatever number, subtracting? Well, it can be multiplication, it can be division, it can be addition, subtraction. So look at the 4 examples and then we'll give you about 2 minutes. Fill in the blanks and write down what exactly you have done to get the next 2 terms. Or subtract 6 in the description box. Okay, subtract 6 or minus 6. What are the two numbers in the next two boxes? Okay, minus 11 minus 6 will give you minus 17. Minus 17 minus 6? Minus 23. Minus 23. Okay, just check. Number 3, what do you do? Divide by 2. Any other answers? Can. Alright, so number 3, you can write the description and divide by 2. It is the same as multiply by half. It's the same. Alright, so that's the description. So the next two answers in your box will be 1 over 8. Divide by 2, you will get 1 over 60. Okay, check. And then the last one will be 1 over 32. Correct. Okay, the last one.
Multiply minus 3.
Multiply negative 3. Is there any other answers that you all have? All of you got the same, huh? So minus 4 minus 3 get 12. 12 multiplied by negative 3 get negative 36. So what are the next two boxes?
Minus 3,
Negative 324. Okay, for n equals to 5. And when n equals to 6, positive, 97 to 907. You don't understand? The last one only, is it? Okay, the last one you can see is minus 4, 12, minus 36, and 108. So after you have observed, you realize the description here is multiply how you get your answer. When the sign keeps alternating, what do you mean by alternating? Minus sign, plus sign, minus sign, plus sign, it's quite likely that you are multiplying with a negative number. Okay? And then you've got to go and discover how you get that number. Of course, from the smaller number, you are able to tell. 4, how to get 12 times 3. But it's not a positive 3, it is a negative 3. And therefore, the change of sign occurs. Okay, Brandon? Okay, before you go on, let's take a look at the box there. An ordered list of numbers. Okay, what you see here, this is called your sequence. Okay, can you write down? This is called your sequence. So minus 4, 12, minus 36, 108, minus 2, 3, 4, and 9, 7, 2, and so on. This thing here is called a sequence. Alright? And it may be generated from some rules or some patterns. Okay, so they gave me an example. And each number in this sequence, we give it a name. Okay, so each number, this is called a term. Yeah, a term. And this is actually the first number, so this is called term 1. This is term 1, this is term 2, term number 3, term 4, term 5, term 6. And because to have an easier representation, rather than keep saying term, right? We use a representation called the TF. So this is your T1, because it's your term 1. This is your term 2, so this is called your T2. And this is your term number 3, this is your T3. Term 4, T4, term 5, T5, term 6, T6. Of course, if there's a number here called n, then that term will be called n. Right? So n can be any number. When n is 1, I'm talking about term 1. When n is 2, I'm talking about term number 2. When n is 3, term number 3, n is 4, term number 4. So n can be any of those terms. N can take any value. Okay? Next page. So the results from the class activity 1, just know what you have done. Okay? You can see that the sequence can be generated from some rules. Because of the short times, we are not going to play. Because the last time I think was you will create your own patterns. Okay? But you cannot tell your friend what you do. And then after that, you switch and then let your friend go and guess what do you do then. Some of them are very, very evil. You're going to do very difficult fraction. Well, the friend think again, 8 find is it multiply or divide, and then a super difficult fraction. But lack of time, we're not going to try that. Okay? Okay, at the bottom, you can see from the 4 examples that sometimes it's always plus something, or minus something, Remember? That is called your common difference. Okay? So common difference is talking about addition or subtraction by a consistent number. Right? So which means, for example, 2, 5, 8, 11. This one is consistently plus 3, plus 3, plus 3. So this is called a common difference. And then you can also have 13, 10, 7, and 4. And this one is consistently minus 3, minus 3, minus 3. So wherever you have addition or subtraction, okay, by a consistent number, fixed number, that is called common difference. Okay, copy these two sequence under common difference. The first one is square numbers. Square numbers. You fill up the blank boxes. So you can see when n is 1, the term 1 is 4. T1 is 4. When n is 2, T2 is, T1 is 1. When n is 2, T2 is 4. When n is 3, T3 is 9. That's it. Yeah. So when n is 5 and 6, you need to find out what is your T5 and your T6. So do you know what it is? By looking at the pattern,
Pi square.
it's pi square, which is 25, and the other one is 36. Yes. So in your description, you can write that pi square is 25 and 6 square is 36. That means you square the n. Can you see? You actually square the n, right? When n is 5, you take 5 and you square it, you get the term 5. When n is 6, you square the term. You square 6, you get the 6. So over there you can describe it as squaring the n. You agree? You square the n, right? So under your description you can say they're squaring the n. And that is but 1. T5 and your T6. And what do you get these two terms? Look at the pattern. When it's 1, n is 1, T1 is 1. Yes, Kayla saw it. It's cube, right? So you want to get T5, you have to cube it. Then that's how you get your 125. Then you have to cube your 6. You get 216. So these two are your numbers. And of course the description you can say cubing the n. Right? You cube the n. 125 and 216. You want to try the rest of it? No. You want to try first. Triangular number. Anybody want to tell me what is a triangular number? Like that one, like triangle. Of course, that's why it's called triangular number. Right? Actually, all these are some patterns. So a triangular number, in the patterns I can use drawing to represent. Triangular number will be something like that first. There's only one. Then my second one, it looks like this. Then the next one is 6, right? Yeah. So you will have 1, 2, 3, 4, 5, 6. And then of course you can go on. 1, 2, 3, 4, 1, 2, 3, 1, 2. Wait, how many? 5, 6, 7, 8, 9. So as you can see, this number pattern is started with a dot. If I draw dotted line, can you see? And that's why this sequence of number, they are called the triangular numbers. Okay? So you can see 1, 3, 6, 10. What do you think is the next one? How to draw? Draw also can. But if I give you 100, then you die. There's a typo error when you describe. I mean, if you can see, describe in words how you get the next two terms, not a next term. The next term. another way of seeing the triangular numbers.
What's the Fibonacci?
Okay, Fibonacci. Okay, come, maybe let Gina explain how she sees without looking at this. 1, 2, 3, 6, 4, 10. Okay, now. How you actually see the sequence from the table. Not like this. Now please listen to her explanation and see whether you understand. Can you see what she Can you see how she add and she get the next term? Okay. You get 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6. And also smart. It's not wrong. It's okay. Okay. So in the description, you can just write down how you get the answer. 10 plus 5 equals 15. And then another one will be 15 plus 6 equals 21. The description a bit hard to write on the pen. So you may want to draw on the table like what Regina has shown you. Another way of looking. Draw on the table. Yes. You want to like to go to the toilet? I'm going to the toilet. I want to go to the toilet. Okay, the last one is Fibonacci numbers. What is Fibonacci? There is also a way. You know what? Okay, somebody wants to explain. Can I explain this?
Regina wants to explain.
Regina or Anna?
No, Regina.
Okay, the next one, Fibonacci. Okay, maybe before we get them to explain what is it first, are you able to find out the pattern and tell me the two numbers? 34 and 55. The next sequence and then explore first. Give a while to take a look. This one is harder to see, not as simple as the first view. 100% accurate, but This one originally is like only 1, but now you have 2. And then here originally in the middle there's 1, now you have 2. So you added 1 more. So actually this one is a what? Yeah, it's a 5 plus 3, right? 5. And then here I added 3 more, so there are 8 here. Okay, let's observe and see how we actually do this. The next one, you have 3 now in the middle. Okay, so 1 here, 1 here. Then here should have okay, so this is my figure 3. So from here, what can you see? I added in how many more? Also 3 more. 1, 2, 3. So 8 plus 3, 11. So you can see here, when you write down in part 3, how do you get from figure 1 to make figure 2, figure 3 to make figure 4, figure 4? You know, so you always add in 3 more extra squares. You write that in the description of part 3. Yeah, at 3. In the previous figure, you get the whole figure. Okay, this one will be sometimes put in the n. 1, 2, 3, 4, 6, 10. Then this one is 10, 5, 8, 11, 14. No? Then this one is pattern. Okay, let's take a look at this. Basically what we want to do is we want to find a pattern to see how we can generate the 6, the 10 and even the n. And n is still can be 100 more. But you don't expect me to keep adding, right? And then I must add my 99 figure plus 3 to see 100 or how much we are paying, right? So first over here, how do you get this pattern? Anybody want to suggest? Times 3 plus 2 times 3. So what times 3? 1 times 3. 1 times 3. So it's 1 times 3 plus 2. So I will get my 5. So here I get 5. Let's try using the same way and see whether I can get my second term, which is 8. So times 3 means now is pattern number 2, so in the bracket you will put 2. Okay, then 3 times 2 is 6. 6 plus 2 is 8. Yes, I get my second pattern. Then the next one, let's check. 3 times of 3 is 9. 9 plus 2, 11. Okay, correct. Then the next pattern, 3 times 4. 4 plus 2 is 14. So it looks like after testing for 4, I know that this one I think is quite correct. I can even without drawing tell you how many squares there are for pattern number 6. So that will be 3 times 6 plus 2, and that will give me 8. So that 10 over there is 20. Then can you find for me number 10? Huh? 32? 32? How you get 32? Let's check. So it's 3 times 10, because n is 10, then plus 2, yes, it's 32. How about this n? 3 times n plus, so it's 3n plus 2. So there is 3n plus 2. So this is how we can generate the general term. So the general term, how do we write it? Please add it underneath. All these things I'm writing here, you fill inside the table. Okay? Yeah. And then at the end of table, this important statement. How do we write the general statement? We write it this way. We will write it as Tn equals 3n plus 1. This is actually the general. So Tn is 3n plus 1. So in questions when they ask you for the general term, they are asking to find what is this. So if the general term in this case is 3n plus 1. Okay, part 5. Now with the general term, you can do a lot of things. So if I tell you that in the figure, I have a total of 290 house or square, whatever you call it. Do you know which figure is that? You get 6. So of course you don't expect me to go and draw 290 tiles to find which figure is there, right? I can use my general formula to help. So how do I do it? So you can say 3n plus 2 must be 290 over 3. That means the total number of tiles must be 290 tiles. So if I want to find my n, so what number times 3 plus 2 will be 290? What will you find? What will you do?
290
You take 290 minus 2 first, then divided by 3. The answer divided by, press your calculator, you will get 6. So that is at figure 96, the total number of tiles or squares is going to be 290. Yes. You are sorry. What is the difference? Minus 5. Minus 5 divided by 3. Oh. So how do you write that? What minus 5?
290 minus 5.
290 minus 5 divided by 3
Plus 1.
then plus 1. How do you get this from here? Actually it's the same. So when it's 5, you take 5. 5 minus. No, how you get? So if let's say look at the first one, then it's a formula, it's not that you get. What's the formula?
This is
How is the formula?
number of tiles minus the number of tiles plus
Every number actually is not plus 3. Every number actually. So what's the formula? What? So when this is 290, how?
minus
1 minus 5.
So the first one is 5.
The first one is 5. So it's 1 minus 5 is 15. 15 divided by 3.
5. Then you add it plus 5 and plus 1.
Oh, okay. I won't say it's wrong, it's correct. But it's just that it's a very complicated way of writing your formula. So how does your formula look like? Yours will not look like this one. So Tn is equal to, you have to take what? N? 5n. N minus 5 divided by 3 plus 1. N minus 5. Very funny because if I try and test it out, this one, when n is 1. So when n is 1 means I'm looking for term 1, right? So n is 1 minus 5, which is minus 4, divided by 2. Tn. Oh, not now. Normally you can't do this. Very difficult. This one is possible if I give you all a lot of numbers. But if not, maybe sometimes writing out this portion. Because your Tn inside here, I will not expect Tn. You are supposed to find Tn, which is the general term. Okay? This method is possible for you to find the numbers here, but when it comes to writing Tn, you have difficulty writing this. Yeah, I know, but your formula is actually Tn minus 5, it's not n. So if I ask you to find the general term Tn, then here you have again Tn. You know what I'm saying? So maybe that's a difficult part. But the way to do it from the table is not wrong, but you have difficulty writing out the general term. You can try it again later and see whether you get other terms. Yeah. You have to come up with the general term in exam. Okay? Next page, we'll do a few more practice later and then you see whether your method is still applicable. Okay, next page, let's fill in the blank. The nth term of a sequence is called the general term. Fill it in, please. Then why is there a need to find general term? Okay,
It's the general term of the sequence.
yeah, the general term of a sequence. A general term is like a formula. And you can find any of those terms if you have the general term. Okay? So how to find general term? Predict the next two terms in the sequence. Describe them in words what you did to generate the next two terms. Predict the general term and look back and check. Okay, we'll try and do this later with a few more examples. Okay, the last part. You want to fill in. The first one, number of square is 1. The second one, number of square is 5. Correct? Count out, wait, count. The third one, the number of square is 9. Correct? You're going to count the number of square. The fourth one, don't have. But do you really need to draw it out? Only right? Can you do some pattern recognition? Can you recognize any pattern? My n is 1. This n. This one is n. This 1. When it's 2, okay, I don't use these terms. I write the figure number. And then here is number of squares. So when it's 2 is 5, when it's 3 is 9, when it's 4 is 13. 5. Oh, how you know it's 13 then? It's short. So you can see a pattern coming out, right? Plus 4, plus 4, plus 4. So next one plus 4, 17. So I want you to add in one more. N. How? That means I'm asking you to find the general term.
Bless you. Thank you.
From here, how to find the general term?
So n.
Huh? What is your pattern?
Minus 4 minus 3.
Times 4 minus 3, let's check. She says it's times 4. What times 4? Try and always use back the figure number. In this case, figure number is n. Okay? So 4 times 4. So 4 times n minus 3. You suspect this is your general term, right? So let's check whether what they say is correct. So when n is 1, you substitute in, you will have 4 times 1 minus 3. What do you get? 1. Yes, it's correct because the first one is really 1. And then when n is 2, let's check. 4 times 2 is 8. 8 minus 3 is 5. Correct. The second term is really 5. So let's check a few more. N is 3. 4 times 3 is 12. 12 minus 3, 9. Correct. When n is 4, 4 times 4 is 16. 16 minus 3, 13. So can you see? I checked 5 numbers and using that formula that your friend proposed, I realize I can always get back the number of squares inside the sequence. So do you think this general term is correct?
Yes.
Answer is yes.
Yes.
So the n here is 4n minus 3. How many of you still find so hard? How do you know? You just wow, ta-da, you can see.
Yes.
Okay. After this, I will teach you a strategy. There is a way to help you find the general term if only general term for common difference. There's a way to find the general term if the sequence has a common difference. Common ratio, it's really sometimes you have to check. Not so easy. But common difference is easier. Okay, let's continue with the last part of the notes. How many squares are there? In figure 10. Figure 10 means n will take the value of 10. So n is 10. 4 times 10 minus 3, that will give you 37. Right. Explain why is it impossible to have a figure that has 320 squares.
I know.
Yes, Kira. Sorry, you take what minus 3? 320.
Minus 3.
You minus 3, yeah?
Well, actually, it's a multiple of 4.
Oh. Minus 3 or what? Plus 3. Okay, so how do I know?
No, sorry, plus 3, plus 3.
Yeah. That's why I'm asking you plus 3 or minus 3. So now how do I know if 320 squares? Okay, how do I know if the sequence, the pattern will have a figure that has 320 squares? Answer is number.
The figure is not a number.
Yeah. So you cannot say like that, must show some working. So your answer is no. Okay, do some working. Is it what working? No, because 300 plus 3 give you 323. And 323 is not a multiple of 4. Okay?
Yes.
Another way of saying is you can take 323 divided by 4, you get some funny decimals.
79.
So since n is not a whole number, there is no sequence with 320 squares. So there are a few ways of saying. Either you say that it is not a multiple of 3 because you add 3 then 323 is not a multiple of 4. That is one way. Another way you can do a division and you realize you got decimals. So you cannot have figure 1, 2, 3, you cannot have figure 70.5, right? Okay, the figure must be a whole number. Figure 1, figure 2, figure 3, figure 10, figure 20. You have figure 70.5, no such thing. So when the number you get is not a whole number, the n, then you can say that there is no sequence that has 300 squares. Okay, these kind of questions are considered a higher order. So which means you need to have some idea to get the general formula and use that to help you justify whether possible. So far, okay. Okay, let's look at this sequence. Just now remember I was telling you that it's a way. Okay, let's get somebody to think of a sequence that is a common difference. Just give me a sequence that is a common difference. But you don't need to tell me what is it. I can tell you what's the general formula. Think of a sequence that has a common difference. For example, I think 2, 4, 6. tell me about it, yeah? 3, 5, 7. So easy to see. You want to make it harder for me? Okay. Okay, let me just show you. You have spoken for about now. 7, 19. You want 1 million lah? Okay, 31. Okay, fine. That is good enough. So from here, right? Let me think. Let me work on my general numbers. General formula. Okay, how do I do this? Let's check. That means when T1, that means first term, will be 12 times 1 minus 5. 7, correct? Yes. And about yeah. T is 2, 12 times 2, 24 minus 5. 15. Yes. When T is 3, 12 times 3, 36 minus 5. Okay, now the question is, how did Madam Wu come up with the general formula so fast? How can you slowly find out okay lah? There is no way. Yes. I'm not wrong, but before I say first. Oh, you want to say first? Okay lah, you put down the hand first. Say first. She has some parts of it. She said because I know, and this is a super important one, I only say one time. Because the difference is always plus 12. Okay, correct? Always plus 12, right? So in your formula, there will be a 12. So if it's always plus 2, you will have a 2n. If it's always minus 8, you will have a minus 8n. So how okay? Yes. How did I get my minus 5? Thank you. 12 minus 7 is a reason how I can get, but there's a very systematic way. Now look here. This one maybe some other classes may not know. So you are very privileged. This is 91. This is 92. This is 93, right? I want to find T0. So if this is always plus 12, I want to go backwards. What is this number? Is a minus 1. So a very easy way to find your Tn is find the common difference times n, and this number behind is actually your T0. Yes, you can copy down somewhere. Then you can test it out. I give you a sequence, then you test out this and see whether you understand. life. Maybe I don't know. Then give your friend another 1 minute to work out this one. Yes. Yes. Who chose the code and the code?
It's so irrelevant for them.
It should be okay. That means when you can't solve a question, it's very hard to find when solving.
Always minus 3. Okay, so in your general term you will have a minus 3n. Then next you have to find, this is your first term, so this is your T1, this is your T2, this is your T3. So I need to work out my T0. So minus 3, if I have to work backwards, what minus 3 will give me minus 10? Minus 7, minus 7 minus 3 will give you minus 10. So your T0 is a minus 7. So you can always check whether this general term is correct or wrong. So if T1 it will be minus 3 times 1 minus 7. So it will be minus 10, correct? T2 minus 3 times n is 2 now, minus 7. So minus 6 minus 7 minus 13, also correct. T3 minus 3 times 3 minus 9 minus 7. So once you check about 3 or 4 terms and the formula works, that means this general term is correct. Any question? So if this is okay, then this is the end of number patterns. Yay!